Okay, right. In this video we'll talk about graph of fractional part of x, and precisely a function is of y equals f of fractional part of x, where fractional part lies between 0 to 1. So we are talking about the transformation of x, not fx. Earlier in greatest integer of, when we were talking about graph of greatest integer function, the first one was fx and then greatest integer. The second was f and input to f was greatest integer x. Now here we are talking about this particular graph being replaced by fractional part of x, not this one but this one. Okay, and suppose first graph is simply f of x equals fractional part of x. Now fractional part of x equals x minus integer part of this x. Now suppose my x lies between 0 to 1, which means greatest integer of it is 0. So fractional part of x equals x. If my x belongs 1 to 2, then greatest integer is 1 and fractional part of x equals x minus 1. If x belongs 2 to 3, then x minus 2. Likewise, between minus 1 to 1, this is x plus 1, and between minus 2 to minus 1, x plus 2. So we have categorized these definition of fractional part of x in terms of different domain of x. Now what is this x? Line passing through origin. What is x minus 1? Simply translation of this curve by 1. X minus 2, again translation of this curve. This is moving in this direction and these two lines are moving in this direction. However, what we are supposed to do, we need to retain this x for 0 to 1. So 0 to 1, we are talking about this particular graph. Then this particular graph x minus 1, when x lies 1 to 2, so we will be keeping this part and then this part and then this part and then this part for different domains, and the graph is drawn here. This is values of x 0, 1, 2, 3, 4, minus 1, minus 2. Between 0 to 1, fractional part is simply x. So this is y equals x, this particular part. This is y equals x. Between 1 to 2, this line is x minus part, rather part of line segment is x minus 1. Then this is x minus 2, x minus 3, x plus 1. This is y equals x plus 1. This is y equals x plus 2. It was very lengthy but essential, necessary. Okay, what we actually observed is this thing. Fractional part of x equals x whenever x lies between 0 to 1, and then simply translation of these graphs, and period of this fractional part of x is 1. That's it, we are done here. Fractional part of x equals x whenever x lies between 0 to 1, and period of that particular graph is 1. That's it. Suppose my graph is f of x equals e raised power fractional part of x, which means this value equals e raised power x whenever x lies between 0 to 1, and then period of this graph is 1. Okay, so we draw exponential curve, retain this part between 0 to 1, erase the rest of the part, and then period is 1. This is my graph. This value is 1 and this is e. This graph is e raised power x, and then you can see this is e raised power x minus 1, e raised power x minus 2. Okay, suppose my next graph is f of x equals fractional part of x and then a square, which means this graph equals x square. Between 0 to 1, draw x square. This is between 0 to 1, retain this particular part and erase rest of the graph. This is y equals x square. Y coordinate 0 to 1, and then period is 1. So just keep on emulating it in different directions. Suppose f of x equals square root of fractional part, which means this equals square root of x whenever x lies between 0 to 1. Draw this particular graph. This is 0 to 1, 0 to 1. Retain this particular part, erase the rest of the part, and then this is y equals under root of x from 0 to 1, and then period is 1. Suppose my graph is f of x equals log of fractional part of x. Again, this equals log of x between 0 to 1. However, one change is x cannot be 0. Draw log x. Okay, retain this particular part and then erase everything else, and period is 1. Now this is interesting. Log x, domain of log x is positive, but domain of log of fractional part of x. Okay, this implies one thing, that x can be negative and then integer part must be excluded. Okay, this is the reason you won't be getting any. These are arrows. Arrows means discontinuity. So domain of this is x cannot be integer, however x can be negative. Okay, suppose f of x equals sine of fractional part of x. Draw sine x between 0 to 1. 0 to 1 means somewhat 55 degrees. This is the part of graph we are talking about. This y coordinate is sine 1 and then period is 1. Why period is 1? It's not very difficult to understand. Those who must have done functions are aware of it. But suppose x equals this fractional part of x. If you put x equals 0.1, output is 0.1. If you put 1.1, output is 1. 2.1, output is 1. Because simply you are excluding part greatest integer of it, and that is being increased by exactly 1. Okay, done.